So welcome back, everyone. This is Fabian from Fabian Electrical Services, Inc. Tonight we're diving into GFCI protection, AFCI breakers, and surge protection according to the OESC 2024 electrical code. So again, I'd like to thank you guys all for tuning in to tonight's live stream. Again, as you guys come in, also please don't forget to like up the live. And we're going to be diving into AFCI and GFCI protection, and what's the difference. But first, I want to run a quick video here for all those who are checking in to the live stream. Again, welcome back. And again, as you guys come in, don't forget to like up the live. So again, basically what this is going to be our set of arc faults breakers, and arc fault breakers are basically used for any little arcing that's going to take place. It's going to detect the overheating of the circuit. So a lot of times, 100% of the times in homes where we are located, I'm not sure in other countries what's the difference, but we have to put arc fault protection throughout the home on most circuits, except for your kitchen 20 amp countertop receptacles, and so on. Your fridge doesn't call for one. Dishwasher is basically a straight connection. You also have anything else that's dealing with normal receptacles in the bedroom, in the garage that's attached to the house, even outdoor, also takes an arc fault receptacle also. A lot of times motors don't take one, so you have your pumps. That's a straight up 20 amp or 15 amp, depending on what it's drawing. So again, it's very important to know the difference also when it comes to arc fault and GFCI circuits. They both do two different, they both do perform differently. And again, one is basically to detect the overheating current, anything that's going wrong with the circuit. The arc fault is going to detect it. And it's funny because I believe I was on another another web, and I saw them say some stuff. So some stuff that I learned about it. So here, this is the GFCI. GFCI normally you use that in the washroom. GFCI protection for the water. Again, that's basically going to stop any leakage of water from getting in, and you know, if there's water, you come in contact with it, current flows through you. So the GFCI is there for a reason. A lot of times when we install the GFCI inside the washroom, it has to be a certain distance from the sink itself. Also, I just found out also during an inspection that GFCI's um, your fridge, if it's a certain distance away from the sink, it calls for a GFCI receptacle, and I believe I showed it just now in the GFCI. So that was a protection, a rule that I never came across before, but I did come across it a couple of weeks ago while I was having an inspection, and you learn as you go. So it was the first time I experienced it, and the inspector brought it out to me and said I needed a GFCI there. Obviously, I never figured it is close to the water, and obviously with the fridge never being on a GFCI before and the position it was in, location, it called for one. Normally the fridges are not in front of the water. They're tucked away in a well-designed area, but this one wasn't. So I had to put the GFCI there. So again, GFCI protects you when it comes to the actual um, water itself. Again, it's a reset button you press, and you can simply reset that. Another one, GFCI, is a GFCI art fall. It's ground fault interrupter. This one is for mostly when you're running your aluminum cable, and you do not want to use the regular art fault breaker at the panel itself. You normally will run the BX to the first location, which would be the receptacle itself, and because the receptacle is in an area where it's not really considered a kitchen, it's a counter or any other receptacle that you're installing in the home that's a 20 amp, it does call for a art fall. There's something called a dead front. We use it a lot. You can basically put that at the beginning of the circuit outside of the panel. It's going to protect it also. Or if you run your aluminum cable to the location, you can simply put it on a regular breaker and then have the GFCI art fault in that location, where it's considered it's not really a full-size kitchen, and that's how we go around that scenario. So again, I'm going to try to pull up a video here. Not sure if I'm going to be able to share the screen. and it's powering both your lights and outlets, you just made one of the most common wiring mistakes I see on job sites. Today I'll be explaining why mixing lighting and receptacle circuits on the same arc fault breaker is a bad idea and how it can lead to hours of wasted troubleshooting. The breaker and lighting itself causes the trip due to arc fault detection sensitivity. So always remember when you do want to test, make sure you use your plug-in tester for safe and accurate reading to determine if your hot and your neutral is in the reverse position, or even sometimes your grounding could be in the reverse also. Arc fault breakers monitoring current flow for irregularities. When you combine different types of loads like lightning, ballast, and receptacles, the noise and harmonics can trigger a fault strip. Add shear neutrals into the mix, and the breaker thinks it's seeing an arc fault, even if everything is wired right. So always remember, when possible, don't combine both lighting and receptacles on the same circuit. It can cause a big issue once it comes to troubleshooting. 26652. Branch circuits below ground in areas designed as flood or hazard. Where branch circuits are located below ground level in areas designed as flood hazard zones, ground fault protection shall be provided to de-energize all normally underground conductors with your ground fault settings sufficient to allow normal operation of connected loads under normal conditions. 26700 General C Appendix B. I go to 2 except provided for by all other rules of this code. Receptacles having configuration in accordance with diagrams 1 and 2 shall be connected only to circuits having a nominal system voltage and ampere rating corresponding to the rating of the configuration. So basically what I try to avoid running circuits like lightning and receptacles together, and avoid sharing neutrals between AFCI circuits unless the breaker is designed for it, like a two-pole AFC for multi-wire branch circuits. So remember, separate your circuits, avoid unnecessary trips, and make your life a whole lot easier. Subscribe for more troubleshooting guides and electrical code tips. Share, and I'll see you. Going to stop sharing that actually. I don't know what's going to come up next here. Let me stop sharing that. So hello again, and welcome back to the channel. I'd like to thank you guys all for tuning in to uh, Fabian Electrical Services Inc. And again, tonight we're simply going over the what it takes for the art fault break, the GFCI protection. I'm basically going to be explaining that. I've explained a little bit of it during the video of the GFCI protection. I've also explained the AFCI breaker wiring and how it basically works. Um, I haven't done the surge protection as yet, so I'm going to just explain a little bit more. Basically, what um, it is. So again, an AFCI is a product that is designed to detect a wide range of arcing electrical faults to help reduce the electrical system from being an ignition source of fire. Overcurrent protection devices do not detect low-level hazards or arcing currents that have the potential to initiate electrical fires. So basically what this is saying is an arc fault circuit interrupter is a device that detects dangerous electrical arcs and shuts off the power to prevent fires. It works by distinguishing between harmless normal arcs like those from a switch and dangerous arcs caused by damaged wiring or loose connections, which can generate extreme heat. So in reality, in terms, that's saying that when the arc fault detects a lot of heat. For instance, if you're using maybe you'll find when you're using a vacuum or a blow dryer of some sort, anything that's high arcing, even a saw. If you have an arc fault on it, it's going to continuously trip the arc fault. Reason being is because the arc fault is detecting the heat. It's detecting the overcurrent, so it's going to do what it does best, which is shut the circuit off to prevent any fires from happening. That's what the arc fault does. Again, for all those who are tuned in to the live stream, as you guys come in, don't forget to tap the like button. Helps with the channel. Um, And again, so dangerous arc caused by damaged wiring or loose connection, which can generate extreme heat. So when a dangerous arc is detected, the SCID energizes the circuit, similar to how a standard circuit breaker works, but with the added ability to identify and respond to arcs. So basically, your regular breaker will sometimes shut off. This arc fault breaker works 100% once set the proper way, and it's going to detect what it's supposed to detect. It's going to stop the arcing, stop the fire from happening. How it works, continuous monitoring, and AFCI constantly monitors the electrical circuit for the unit electrical signature of a dangerous arc. Distinguishing arcs, it uses advanced electronics to tell the difference between a normal harmless arc, which it ignores, and an abnormal arc that poses a fire risk. And the safety measures. It's basically dangerous arcs can occur due to broken wires, pinch cords, or loose connections, and can produce enough heat to ignite surrounding materials. Trips, it will then trips the circuit, and again, when an unsafe arc is identified, the ASCI opens its internal contacts to quickly shut off the flow of electricity to that circuit, and then stopping obviously the risk of a fire. Again, you're going to see that it's going to have serious arcing occurs when there's a break in a wire, causing electricity to jump across the gap, which can become very dangerous. Parallel arcing happens when electricity jumps from a damaged wire to another wire, like a neutral or ground. Again, that's probably why sometimes you'll see that you will I believe that's called dirty power. Is what that is. Loose connection prevents fires caused by loose connections at outlets or switches, which can become hot and spark. That's another thing why you always use your Morex to close off your connections. That's what they're there for, to use them, and it helps protect you against what's going to pretty much happen. So I'm going to just play a quick video here meanwhile, and then I'm going to get into the GFCI itself. So I'm going to run a quick video here. So again, I'd like to thank you guys all for tuning in to tonight's live stream. Again, as you guys come in, don't forget to like up the live stream. Very important. Please and thank you. So hello, welcome back to my channel. I'd like to thank you guys all for tuning in to today's lesson. We are simply going to be installing my receptacles. So again, welcome back to the channel. We're going to simply doing this receptacles right now. So again, hello and welcome back to the channel. I'd like to thank you guys all for tuning into tonight's live stream. Again, this room here is basically regular receptacles that is being installed. 15 amp tamper receptacles, which is going to carry again the AFCI protection, the arc fault protection. Why is it carrying that? Because the OESC 2024 states that receptacles, 15 amps, 20 amps, I believe, will carry an arc fault breaker. Again, when it's in the bedroom also, arc faults are installed for the bedrooms, the hallways, for the arcing and the protection of for instance, when you're going to have the TV, the TV is something that's going to overheat. Your computers are going to overheat. Also, a lot of times people will install the receptacles, but they will not take into account for the TV itself. Most of the time, it's better to have the TV on its own, but if it's not on its own, you can, as long as you have that whole circuit with an arc fault. Again, you have your heaters, your normal heaters, not your baseboards heaters, but those fancy heaters that they're installed inside of the below the TV. A lot of times too, those are arc fault protected. The only way it's not is if it comes with an end where it's going to require direct connection. I don't believe it needs an arc fault then. Anything with a direct connection, even the your microwave inside of your kitchen takes an arc fault also if it's not a direct connection. So these are things that will require the arc fault protection. Again, the washroom, it takes the GFCI protection. The pool itself, it takes the ground fault interrupter with the hill itself. That's something totally another thing that's different. So again, as I was saying, I'm going to run over, go over the GFCI. So a GFCI outlet is a safety device that protects against electrical shocks by shutting off power when it detects an imbalance in the electrical current, a ground fault. This imbalance caused by electricity taking an unattended path, like through a person or into water, like I mentioned before, can be prevented by a GFCI outlet that senses even a tiny current difference around 5 milliamps and trips in a fraction of a second to prevent a severe or fatal shock. Again, they are required in areas with water such as kitchen, bathrooms, and outdoors. A GFCI monitors the current flowing to a device and the current returning from it. Under normal conditions, the amount of current going out should be equal to the amount coming back in. And again, in the GFCI detects a difference. If the GFCI detects a difference of about 5 milliamps, it means some current is being diverted, a ground fault. the GFCI immediately cuts the power to prevent a shock, protecting you from potential electrocution, burns, or other injuries. So again, the $10, $15 you're going to spend for the GFCI is worth it. It's going to give you the protection that you need. A lot of times people are hesitant, but it is required again under the OESC 2024. And again, why GFCI outlets are important. They prevent electrocution and severe electrical shocks by quickly interrupting the flow of electricity. Again, they can also prevent fires and reduce the severity of fires by interrupting the current during a ground fault. There are crucial safety features in areas where electrical devices are used near water, such as in kitchens, bathrooms, laundry rooms, garage, and outdoors. Again, outdoor, you're going to find them for the protecting of the outdoor circuit. Um, Again, what they don't protect against, GFCI's outlets do not protect against all electrical hazards, such as a person holding two hot wires at the same time. They are not designed to protect equipment from short circuit, which is the job of a standard circuit breaker. Um, so again, that's your little um, that's basically the explanation of a GFCI. I'm going to again run another video, and I'm going to get into the surge protection here. So again, under the electrical code, your surge protection device must be properly bounded. If you're wiring a GFCI outlet or installing an AFCI breaker, remember these OESC 2024 updates help. So again, hello, welcome back. Again, this is not going to be a long life tonight. So again, what is a surge protection? A surge protector, also known as a surge suppressor, is a device that is made to protect electronic equipment from unwanted power, surges, or spikes. It takes only a tiny amount of voltage increase to damage most of today's sensitive electronics. Again, surge protector is a device that safeguards electronic equipment from damaging power surges, which are sudden, temporary increases in voltage. It works by absorbing excess energy from a power spike and diverting it to the ground wire, protecting connected devices from potential damages. Again, it diverts excess energy when a power surge occurs. Internal components, most commonly metal oxide resistors or MOVs, conducts the excess current and divert it to the ground wire instead of allowing it to flow to your electronics. Limits voltage. It limits the voltage supplied to the device to a safe predetermined threshold. And again, it protects from various causes Surges can be caused by lightning, high power appliances cycling on and off, or problems with your home wiring. Key features to look for is Joule rating. This indicates the amount of energy the surge protector can absorb before it fails. A higher rating offers more protection. Indicator lights. Some surge protectors have lights to confirm they are functioning correctly and protecting your devices. And data line protection. Some models offer additional protection for data lines such as coaxial and Ethernet cable. Surge protectors versus power strips. Do not confuse a surge protector with a power strip, which simply provides multiple outlets and offers no protection against power surge. So the regular plug-in cords that you use that have multiple outlets. It's just a normal power strip, which is not going to really do anything when it comes to protecting your devices. So again, look for labels indicating surge protection, surge suppressors, or jury rating on the packaging to ensure you are getting a true surge protector. So again, that's the explanation of the surge protection. Again, it's helps to protect your equipment and so on, depending on what you're doing. In case of a lightning or in case of your power going off and you have stuff that you don't want to get damaged, that's what you normally will use. So people who are located in places where they're going to have a lot of rain, a lot of storms and stuff like that, even blackouts and stuff like that, will probably benefit from that. Uh, So that was the explanation of the GFCI protection, AFCI breakers, and surge protection. Again, according to the OESC 2024 electrical code. And again, under the electrical Canadian electrical code, your surge protection device must be properly bounded. If you're wiring a GFCI outlet or installing an AFCI breaker, remember these OESC 2024 updates. So I'm going to be running possibly two more videos here before I log off the live. Uh, the same screw. And again, this is just a video. Please, if you guys need to have any work done, please contact a licensed electrical contractor. Okay, now I will install my breakers. Again, also this is an inspection job, so I'm just waiting for the inspector. This power is not live. There's no power to the panel. The panel is not. Hello and welcome back to my channel. And again, as you guys enter, just hit the don't forget to hit the like button. Also, don't forget to subscribe to the channel and like and share the video. And in today's video, this panel is a 100 amp panel located on the second floor of the home, and it's going to be the main supply for the second floor, where it's going to be feeding lighting, receptacles, also there's going to be a boiler up there, and it's going to also have hand towels and so on. So again, sit back and enjoy the video, and I'll catch you guys on the next one. So again, it's just a quick tour. This here is the theater room. Yes, Kubuzi. Most everything here is pot lights. There are a couple center lights upstairs, but everything in the house is pretty. Is pot lights. Yes, these are all speakers on the side here.
1, 2, 3. This is going to be a little small bar kitchen area here. We're going to have a sink here. Eventually, I have to run some type of lighting for the, I believe, for the benches, something like that. Yeah, Movement TV is pretty huge. It's just it's a family, it's a theater room. So now you can see with all the lights on here. Um, it is a pretty big, huge ass house. Yeah, bro, it's pretty huge. Yeah. These are the towels that they're using. I don't want to step on it. I don't think it's fresh, but this is just a back room, and here is going to have the the system for the speakers. And this is the stairs. This is the elevator here. Um, that's going to go all the way up to the second floor. I still have to put a light and a plug inside
So
of
again, if you found this breakdown of
this area, which
AFCI,
is required by
GFCI, and Surge
code.
Protection helpful,
So these
subscribe for
are
more electrical
basically
code tutorials and OESC
my lights
2024 live stream from
that's
Fabian
coming
Electrical
down,
Services Inc.
as you can see.
So again, for
So
all
again,
those who
these
are
are all
tuning in
pot lights
to
that
the
I'm
live
using.
stream, you can catch the live stream on the
In the
replay.
basement, there's no
This will
center
be
light.
the last
In the
video.
basement, it's all pot lights. This area, I still have to put the light in. This is a gym. This area is going to be a gym. So you're not going to see anything right now because it's pretty dark. I still have to do the lighting in here. But yeah, this area is going to have a gym. You can see there are all pot lights in here. This pot lights QBZ. There's no, I didn't put the lighting in right now because I wasn't working.
So again, hello, welcome back to the channel. That was the last video that I was going to be playing for the night. Again, if you found this breakdown of AFCI, GFCI, and Surge Protection helpful, subscribe for more electrical code tutorials and OESC 2024 live stream from Fabian Electrical Services Inc. Again, I'd like to thank you guys all for tuning in to tonight's live stream. Again, don't forget to hit that like button and subscribe to the channel. Make sure that your notification is turned to all so that you do receive my videos and my live streams when I do go live. Just make sure it's hit to all. And I would like to thank you guys all again for tuning in to tonight's live stream. And I will catch you guys on the next live.